Welcome back. In the previous video lecture, we discussed that the observed small positive number for radiative forcing is still sufficient to cause the temperature to increase of oceans and the surface of planet Earth, as observed. The main cause for the energy imbalance is the emission of greenhouse gases like carbon dioxide. Let me introduce you to the carbon cycles of planet Earth. So first, Earth has a natural carbon cycle. In its natural carbon cycle, vegetation on land annually absorbs 40 gigatons of carbon dioxide out of the atmosphere and emits again 440 gigatons of carbon dioxide into the atmosphere. Similarly, the oceans, including its flora and fauna, absorbs 330 gigatons of CO2 and emits again 330 gigatons of CO2 into the atmosphere per year. Humans emit additionally around 40 gigatons of CO2 into the atmosphere by burning fossil and by land use change like deforestation in the tropics. This additionally emitted carbon dioxide is partly absorbed again by the biosphere and oceans that result in the acidification of the oceans. Some of the additional CO2 dissolved in the oceans reacts with water to form carbonic acid. Some of the carbonic acid molecules dissociates again into bicarbonate ions and hydrogen ions. However, a significant part of the by human activity extra emitted CO2 remains in the atmosphere and contributes to the growing concentration of CO2 in the atmosphere. The blanket of greenhouse gases is getting thicker. The Intergovernmental Institute on Climate Change is the United Nations body for assessing the science related to climate change. The IPCC prepares comprehensive assessment reports about the knowledge on climate change, its causes, potential impacts, future risks, and response options. At the date of recording of this video lecture, the IPCC has published in its sixth assessment cycle 3 reports. The first report is on the physical science basis of climate change from 2021. The modeling results of the global surface warming I've shown earlier in the previous video is from this report. The second report is on the impacts, adaptation, and vulnerability of climate change, and the third report is on the mitigation options of climate change. The last 2 reports date from 2022. The first report highlights 5 different scenarios and its impact on climate change in which annual CO2 emissions are subsequently reduced, stabilized, or even increased. I would like to introduce those scenarios to you to get a feel for the numbers. The graph on the left shows the increase in global surface temperature at the end of this century in reference to the period 1850 to 1900 for the various scenarios. The graph on the right shows the evolution of the annual CO2 emissions related to human activity in this century. The first scenario, here indicated in light blue, is a scenario in which the increase in global surface temperature at the end of this century, in reference to the period of 1850 to 1900, is limited to 1.5 degrees Celsius. This corresponds to the most ambitious goal of the Paris Agreement. However, this would mean that by the mid-50s of this century, CO2 emissions should have been reduced to 0, and in the second half of this century, we would need to realize negative CO2 emissions. So negative CO2 emissions implies that we capture and store more CO2 from the atmosphere than we emit into the atmosphere. It shows that right now, from 2022, we have to drastically reduce our CO2 emissions per year. Unfortunately, the real numbers of CO2 emissions from 2021 and 2022 do not show a trend towards a drastic reduction yet. A second scenario, indicated with the dark blue, would be a good indicator for a target corresponding to a 2 degrees Celsius increase in global surface temperature at the end of this century, in reference to the period of 1850 to 1900. In this scenario, negative CO2 emissions in the last 20 years of this century should be achieved. Even in this scenario, significant reductions of CO2 emissions should be achieved in the upcoming years. The third scenario, here in orange, resembles a world in which the CO2 emissions will still slightly increase up to 2040 and stabilize in the 40s and start to drop from the 60s. Such evolution of CO2 emissions would lead to around a 2.7 degrees Celsius temperature increase at the end of this century, which would reflect a disaster scenario, a world in which many habitats would be threatened by frequent extreme weather events. The current trend of CO2 emissions is unfortunately most in line with this scenario. The last two scenarios resemble scenarios in which the CO2 emissions would be doubled or even tripled, including corresponding increase in global temperatures of 3.6 and 4.4 degrees Celsius respectively. It's out of the scope of this video lecture, but the IPCC report tells us further that human-induced climate change is already affecting many weather and climate extremes in every region across the globe. First, evidence of observed changes in extremes such as heat waves, heavy precipitation, droughts, and tropical cyclones, and in particular their attribution to human influences, has further strengthened over the last years. Climate change is already affecting every inhabited region across the globe, with human influence contribution to many observed changes in weather and climate extremes. Secondly, many changes in the climate system become larger in direct relation to increasing global warming or in waters more or increasing CO2 emissions. They include increase in the frequency and intensity of hot extremes, marine heat waves, and heavy precipitation, agriculture and ecological droughts in some regions, and proportion of intense tropical cyclones, as well as reduction in Arctic sea ice, snow cover, and permafrost. These graphs show that if we would like to meet the commitment set in the Paris Agreement, we should act now and realize as soon as possible drastic reductions in the CO2 emissions. That implies that our energy infrastructure, that currently heavily depends on fossil fuels and CO2 emissions, needs to be turned into an energy system based on renewable energy technologies. In such energy transition, renewable electricity, like solar electricity, will become the dominant energy carrier. In the next video, I will discuss the role of solar energy in the energy transition. In summary, in this video lecture, we have discussed the role of greenhouse gas emissions, like CO2, in global warming. The 5 scenarios of evolution of CO2 emissions from the latest IPCC report demonstrates the challenges that lie before us to meet the commitments of the Paris Climate Agreement. It starts with drastic reductions of our CO2 emissions and a crucial energy transition in the upcoming years and decades. In the next video lecture, I will talk about the role of solar energy in the energy transition. So see you in the next video lecture.